This video is going to take a look at how to do geometric and binomial calculations, both with the formula and on your calculator. So let's start with the fact 40% of people have type A blood. What's the probability that the first two people in the room, so the first two people to walk in the room, have type A? Now back to our older videos, you used to ask yourself, is this an and or is this an or question? Most of these are going to be and questions, but sometimes they'll be combinations. But when I say this, let's say the first two people are Mark and Kelsey. Is it Mark or Kelsey have type A blood, or is it Mark and Kelsey have type A blood? And if the answer is and, you're going to multiply. So this means Mark walks into the room with type A blood, Kelsey walks into the room, type A blood. The probability of the first one and the second one have type A blood is 0.16. Here's a different question. What's the probability of the third person to come in the room as the first person with type A blood? So when I think about that, I think they're not type A, and the next one's not type A, but then we get a type A. So you have to go back to the original question. If 40% of people have type A, that means 60% don't. So if there's a 40% probability of having type A blood, there's a 60% probability of not having type A blood. So this is going to be 0.6 times 0.6 times 0.4, which is about 14%. Here is another related probability question. What is the probability that at least one of the first two people has type A blood? I'm going to show you the hard way to do this, and I'm going to show you the easy way to do it, but the easy way to do it requires you to think a little bit outside the box. So here's the hard way to do it. How many ways can this happen? If it says at least one, that means either the first person has type A and the second one doesn't, or the first one doesn't have type A but the second one does, or they both have type A. So when I say what is the probability that at least one of the first two people has type A, that can be the second one, the first one, or both. This is 0.6 times 0.4, 0.24. This is 0.6 times 0.4, 0.24. And this is 0.4 times 0.4, 0.16. And if I add those all up, 16 and 24 is 40. 40 plus 24 is 64. So there's a 64% chance that at least one of the first two people has type A blood. Okay, the easier way requires you to do a little bit more thinking. And what you need to think about is what the opposite is. And so I always say it to myself out loud. The opposite of at least one having type A blood is nobody has type A blood. And so that's 1 minus 0.6 times 0.6. 1 minus 0.36 is 0.64. So it's a much easier calculation, and remember, in probability the opposite is always out of 100%. So when you're saying opposite in probability, you subtract from 1. So this next problem, what you need to focus on is that it says there's a group of 6. As soon as you see that there's some kind of a total, so we're talking about 3 people out of a total of 6, that's like the secret code that tells you that this is a problem that you can use a binomial function for. So if I were to just think about this as a geometric problem, 3 people in a group of 6 having type A, that would be type A, type A, type A, not type A, not type A, not type A. But we also have to think about how many ways this can happen. This can happen in 6 choose 3 different ways. So if you look at the formula for the binomial, it's 6 choose 3. The probability of being type A is 0.4, so 0.4 cubed. That's these 3 numbers. And then the probability of not being type A is 0.6 cubed, because there's 3 of them. And you can either work this out in your calculator with the 6 choose 3 button, or there's another new way to do this on a calculator, and that's to have your calculator do the binomial PDF of 6, 0.4, 3, and this calculation you'll find in the second vars menu on your graphing calculator. Now when I'm reading this question, the first thing I notice is it says in a group of 6. So that tells me it's a binomial question, and it says what's the probability that 2 or fewer have type A blood. So I could have 0 or 1 or 2 or 3 or 4 or 5 or 6 people have type A blood. 2 or fewer is these numbers, and so this first one can happen in 6 choose 0 ways. The second one can happen in 6 choose 1 ways, and the third one can happen in 6 choose 2 ways. And because it's 2 or fewer, that means 0 or 1 or 2. So these are the probabilities I'm going to have to add up. In the first scenario, 6 choose 0 is just there's only one way that can happen, and that means nobody has type A. So it's just 0.6 to the 6th. There's no type A's. Everybody's not type A. So in the next scenario, 6 choose 1, that can happen 6 different ways. And for this problem, we have one person that has type A blood. So the 0.4 is going to be to the first power, that's the one person with type A blood. And the 0.6 is going to be to the 5th power, that's the 5 that don't have type A blood. And you'll want to look like right here and right here, these two numbers are always going to add up to the 6 people in the group. One person with type A, 5 people that don't have type A. Then as we continue, this next number, 6 choose 2, is 15. So there's 15 different ways that you can have 2 people have type A blood. So 0.4 squared, those are your 2 type A's, times 0.6 to the 4th. Again, notice this 2 and this 4 right here add up to 6 because it's a total number of people. There's your 2 that don't have type, 2 have type A. There's your 4 that don't have type A. And you're going to have to add all these up. Now, if you try this on a calculator, you might also want to check out the binomial CDF button in the second vars menu. What the C stands for is cumulative, and the cumulative density function adds up all of the little probabilities for you, and it only adds them from left to right. But if you type this into your calculator as 6, 0.4, 2, it will add up 0, 1, or 2 for you and give you your answer in a single press of the button. The final answer, whether you do it the long way or you use your calculator, verify, you get 54%. So again, as soon as they give us a total, a group of 10 people in this case, that tells us we're dealing with a binomial probability. And you can think about this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people having type A blood. So what's the probability in a group of 10, 3 or more have type A blood? That's this. And that would be really a pain to do, because you would have to add up all of those individual probabilities. So the better way to do this is as the opposite of 2 or fewer have type A. Now, if you wanted to do all the math for 2 or fewer, let's go through that just for a second. It would be 10 choose 0 plus 10 choose 1 plus 10 choose 2, and this would be all of them don't have type A, all 10. This would be 1 has type A and 9 do not. And this would be 2 have type A and 8 do not. And you would add these guys all up, and that would give you the probability. But remember, your calculator does a nice job of adding with the CDF button. So if you were to type in 1 minus binomial CDF of 10, 0.4, 2, it'll give you the opposite of 2 or fewer, which is 3 or more, and you'll have the answer. If you missed it in the earlier slide, but the binomial CDF is in the second VARS menu on your calculator. This next problem is an example of the type of probability problem you'll have on your homework, and also an example of a probability problem a lot of people get wrong. This research was done with gynecologists. About 1% of women who come for mammograms have breast cancer. If a woman has breast cancer, there's a 90% chance that they'll have a positive test. If they don't have breast cancer, there's only a 9% chance of a positive test. That's called a false positive. The question given to the gynecologists was, if a woman tests positive, what should you tell her about the chances she has breast cancer? The answer choices are, she's got an 81% chance of breast cancer. Out of 10 women with positive mammogram, 9 have breast cancer. Out of 10 women with a positive mammogram, 1 has breast cancer. The probability she has breast cancer is 1%. And these are the results when the gynecologist answered the question. Most of the gynecologists thought that this was the answer to the question. 47% of them chose that answer. But let's take a look on a table, just like we did earlier in the chapter, at a hypothetical 100,000 women. 1% have breast cancer, 99% don't. So we've got 1,000 women with cancer, 999,000 who don't have cancer. Now, 90% of those who have cancer test positive. So if you're looking right here, we've got 900 who test positive, 9% who don't have it test positive. So of the people who test positive, 9% don't have cancer. If we then fill out the rest of the chart to add up, right here, 900 and 100 make 1,000, 8,910 and 90,090 add up to 99,000. And we look at the question says, what's the probability to have the cancer given they have a positive test? Well, here's all the ones that had the positive test. And so they're asking this question, 900 out of 9,810, or 92 or 9.2%. That's just under 10% of people who have a positive test have cancer. And what most of the physicians mixed up was they answered the other question. They answered the question, what's the probability they have a positive test out of everybody that has cancer? These are two different questions. In a really sort of funny way, the writers of the pre-calculus book that you guys are using actually got the same question wrong. I can't remember which problem, but I'll mention it in class. And anyway, think about it this way. 53% of gynecologists got this probability question wrong. The people who wrote the pre-calculus book got this question wrong. It's kind of a tricky thing to figure out, but I will be holding you responsible for it. And what you need to think about is whatever they're asking the probability of is what goes first, and whatever they're telling you the total is what goes second.